Hello again, everybody, and welcome back to my YouTube channel. Today I want to talk about how we can count subsets and do it arithmetically as opposed to trying to actually arrange things the way we've done recently. There's a video on page 56 that I would encourage you to watch when you're done watching this screencast. The lesson that I want to talk about, though, with the counting subsets, just understand that what we're talking about is grabbing a bunch of objects out of a larger set, and we're not going to be concerned with their order. And this is, I mentioned this yesterday, is what we call combinations, not to be confused with permutations, which is arrangements. So I'm talking about taking a group of subsets. We've talked about sets before, back in 6th grade, we talked about that. But the denotation that you see here, with this, I got a 10 element set on this figure. And if I'm going to take a 4 element subset, it'll say 4 subset. So for the record, as we look down here, we can see pretty easily that if I say, if I write something like this, we say, wait, those are the same. What's going on here? Well, it just means this. When you're saying 10 out of X or 10 take X, there's a number of different ways we say it. Usually I'll just say 10 choosing X or 10 take X. And so if I've got 10 elements and I take a 1, there's 10 ways I could do that. If there's 10 elements and I take 9, there's also 10 ways to do that. 10 elements choosing 10, there's one way to do it. 10 elements choosing nothing, there's one way to do that as well. So be careful with that. 10 choosing, when I say 10 choosing 0, that's 1. This one here is overlooked a lot or confused a lot. It's only going to be 0 if I'm trying to take more things than are there, and that's what I have on this one right here. 10 choosing 12 equals 0. Yeah, that can't happen, folks. Think about it. It's impossible to select 12 items when presented with 10. So there's some demonstrations down here when it talks about this 10 choosing 4, but you can use product rule for this. As it says here, 10 times 9 times 8 times 7. You know what, I meant to underline that. Let me underline it instead. So 10 times 9 times 8 times 7. That's that's where I can take 4 things and arrange them. But if I don't care about the order, I need to divide away the 4 times 3 times 2 times 1. And when I go to simplify that, as you can see down here, it is 210. On this explanation, I'm just going to try to cut through the red tape a little bit for you here. When I'm saying 10 choosing 4, one way to think about that is simply to say, okay, 10 times 9 times 8 times 7, I stop once I get 4 things, and then I divide it by 4 factorial. In doing so, hopefully you can see that there's some things that can quickly cancel out. The 4 times 2 and the 8, sure. And then, of course, if I choose the 9 and the 3, I can knock those out, make them a 1 and a 3 like that. And now you can more easily see that 10 times 3 times 7 is, in fact, 210. See? So here's a few other examples. 14 choosing 6 is 3003, as you see. 6 choosing 3 will get you 20. 5 choosing 2 will get you 10. Do you see how that math is working? 50 choosing 1 is 50. 20 choosing nothing is 1. 0 choosing 0 is 1. Again, empty set, you understand? It's only when I'm trying to choose something that's larger, like this, 10 choosing 11, can't do it. That's when it's the same. Here's another thing right here that's rather important for you to notice, and that is that n choosing s will always be equivalent to n choosing n minus s. Take a look. 52 choosing 49 will be the same as 52 choosing 3. 52 times 51 times 50, all over 3 times 2 times 1. 22,100. This would have been the same had I, extended it out further. And you'll hopefully you'll understand that as you go to do these. It's easier to see if I do it with a smaller set. If I say 6 choosing 2, based on the algorithm I just showed you, that's 6 times 5 over 2 times 1. Well, that should be equivalent to 6 choosing 4, and that's because 6 times 5 times 4 times 3 over 4 times 3 times 2 times 1. Notice what can cancel out here. 4 times 3 is cancel. See how it's going to be the same? I hope you see that, because that is going to be much, much easier if you look at it that way. Okay, now previously, when remember how when I had those little, we had the, in this case, let's see, we got 5 blanks. I think I did 6 or 8 before. If I've got 5, balls and 2 of them are black, how many ways can I arrange those objects of 2 kinds? You say, wait, isn't this arrangements? Yeah, but it's only 2 distinct things. So this is really the same as subsets. So, and you may have recalled that I could have counted those, and I wound up doing 4 plus 3 plus 2 plus 1. That's not always convenient, though. Instead, consider with, like I said, this kind of arrangement here, if I'm doing those 10 things, I could treat it as 5 choosing 2, which is 5 times 4 over 2 times 1. Behold, it's 10, and I didn't have to draw anything. Now, if we go bigger, 6 white balls and 4 black balls, that one's, you see, whereas this one up here, I was able to, easily write those out. If I've got 10 balls and I'm choosing 4 of them, that's going to be much, much, more difficult to draw out. I will definitely want to use math. 10 choosing 4 can be rewritten as 10 times 9 times 8 times 7, all over 4 times 3 times 2 times 1, which simplifies to 210. See? So, and as it says here, you can generalize this rather simply as m plus n over m equals m plus n over n. And that, of course, is, what I had said. I think I demonstrated that up here with the 6 choosing 2 and 6 choosing 4 up here, right? So if I did that down here, 4 plus 2 choosing 4, let's try it again. 4 plus 2 choosing 4 would be equal to 4 plus 2 choosing 2, which of course, as you know, 4 plus 2 choosing 2 is quite easy to figure out mathematically, right? 6 choosing 4 is equal to 6 choosing 2. So let us complete these exercises 59 through 62, and those are on pages 56 through 61. Again, there's a lot of reading on 56 through 57, as well as the video I told you about. I will see you in class tomorrow. Be good for your parents. Have a great